Awesome. So, hey everyone, and welcome to OpenShift Commons stream. So as you can see, I'm not Karina. So Karina had an injury this week. So let's all hope and wish her a speedy recovery so that she can come back again next week. With that, I have just a quick announcement to make. So don't forget about the registration for OpenShift Commons gathering at KubeCon EU, which is happening in Paris. It should be in 19th of March, 10 to 18 CET. And yeah, don't forget to register there. I think this is going to be a good crowd, good topics out there. With that said, today we have an interesting topic. It has been a buzzword for quite some time. Platform engineering, and we have someone who has quite the experience in the upstream community. So I'd like to switch and hand over to Josh. Gavant, can you introduce yourself and walk us through the realm of platform engineering with OpenShift?
Yes. Thank you so much, Del. This is a real privilege. I'm excited to chat with you all, and I hope we can make this a bit of a conversation. I am a solution architect with Red Hat, supporting customers, trying to build platforms in support of their application developers, build application platforms. I'm also the chair of CNCF's Tag App Delivery and the platforms working group that we have over there, which has been trying to lead the industry these past couple years in understanding what exactly we mean by platforms, what is platform engineering, trying to help people gain understanding, help us all speak a common language, bring people together. So in today's presentation, what I want to focus on is first platform engineering in general. Like I said, what is a platform? What is platform engineering? But also I want to tip down into some of the practical aspects. If you're building a platform, what are the things that you might think about? And I especially want to touch on, I put here in the agenda, portals and orchestrators. And I want to talk about in particular how OpenShift supports platform engineers and the capabilities that we have for platforms in OpenShift. So here's our agenda. Like I said, we'll talk about platforms, we'll talk about platform engineering, and then we'll talk a little bit about the components, some key components of a platform. Always has been platform. So in our, about a year ago, actually KubeCon Amsterdam, our group at CNCF published a paper to try to help people understand when we talk about platform engineering, what exactly do we mean by a platform? Because the word platform, in fact, I want to ask folks in the call, if you want to chime in and tell me your definitions of platform or what it means in your organization, I'd be curious about that. But in CNCF, what we realized is that it's a relatively generic concept, a concept where you're bringing together some collection of capabilities to enable some end user use case. You're bringing those capabilities together in a consistent way. And what we realized is, of course, there's a lot of hype around developer platforms, but it's not really only developer platforms. It's not only for building first-party apps that you might have this kind of collection of capabilities and support. It's the same thing if you're building an MLOps platform, let's say, for machine learning and AI. Or maybe you need to run commercial off-the-shelf software, third-party software. And again, that needs a collection of capabilities to support itself. Of course, first-party software is probably the most important use case to begin with. But that concept of a platform actually could be much bigger than that. And that's kind of what we mean. That's what I mean when I say it's always has been. If you think about it, the evolution of computing platforms, well, there's always been some sort of platform underneath you, whether you're going back, 50 years to reprogrammable machines. Of course, you've got the same machine, you're just rewiring it to be used for a different purpose, but you're utilizing that same set of capabilities. operating systems, I mean, the word platform has been used to describe an operating system before, because an operating system likewise is genericizing a layer of hardware and other capabilities to surface to your applications. A recent kind of platform, which is still plenty valuable, is infrastructure as a service, where you're just getting compute, network, and storage, and yet that's a kind of platform as well, where we're offering those in some sort of consistent way for you to build applications on top of. But where we're really at nowadays, or at least with the platforms that we're talking about in the platform engineering space, is developers are not satisfied, or we're not able to provide sufficient, by just giving compute, network, and storage, that's not enough to enable developers to get their work done. The capabilities they need for their use case, compute, network, and storage, is not exactly enough. We need higher level capabilities that bring that bring the compute, network, and storage together into databases, into message queues, into observability systems, identity systems. And so we end up with this diagram, which ended up becoming pretty popular from our paper, which kind of illustrates, and we tried to capture some of the capabilities that you might expect to find in a modern platform in this graphic. And we kind of tried to show how these are higher level capabilities that layer on top of what you're getting from an infrastructure, the infrastructure side. Yeah. One thing that's interesting about this diagram, and it's going to come up later, is that when we talk about a platform, there are both the core element of the platform itself. So all of the databases and the messaging systems, identity systems, pipeline systems, build systems that you might be running to actually implement operations in your platform. And then there are all the interfaces, the ways that you interact with the platform, which starts from APIs and CLIs, but of course includes things like graphical user interfaces and web portals, which we'll talk about as well. So yeah, I am curious, does anybody else here have a different take on how you might define a platform, or how you define a platform in your organization?
I see other folks joined the call a bit late. Yeah, so.
Yeah, well, think about it, and as we go along, just come off mute and raise your hand if you have a different opinion. One thing that I wanted to talk about is, if this has always been this way, why did platform engineering emerge now in particular? And I like to use this graphic to kind of set the stage. This is an application that I actually built like 5 or 6 years ago, which has a couple microservices. In the center, you see there's a Go service that calls out to a Java service. But what's more interesting is everything that has to go around this service. It relies on databases and queues. It relies on blob storage. It needs some sort of artifact store to store images or to store other packages. There's an observability system. There's a directory system. So whereas in possibly 20 years ago, a lot of these capabilities came from the operating system, let's say, from the OS platform, in the cloud, it's no longer happening that way. These capabilities are getting distributed out across the environment in the same way as your microservices are getting distributed out. So suddenly, it's no longer sufficient to just rely on the developer to use something from within the operating system. It becomes necessary for them to integrate pieces from all around your environment. So you end up with this collection of distributed capabilities. And this has made it more important for somebody to maintain and make available these distributed capabilities, to provide that platform to the end user, to the app dev. Here's this list. This actually comes from that first paper, and it was an attempt by us, and a hypothesis, I always like to say. And that's another question that I would like to bring up with the group. I'm always curious, what are the capabilities that are in your platform? What were the most important to you? We listed, we put portals and APIs up at the top, and that's the first thing you see. But there's a lot that comes underneath. Sometimes it's almost like an iceberg where you just, the APIs and the interfaces are at the top, but there's a lot of capabilities down underneath. Yeah, I'd be curious, if anyone wants to come off mute at some point and talk about capabilities that they've prioritized in their environment and what they consider to be key capabilities in a platform.
I would say API first. So basically, whatever you want to provide through a portal or through a dashboard, it has to have a corresponding API so you can automate it.
+1. Yeah, you always want an API. The portal comes second.
I would agree with that as well. So I think API first for all of these things, but I think specifically security, observability, I think are probably two of the biggest things that we are always concerned about. So yeah, those areas, but yes, absolutely, API first.
Yeah, that's interesting that you bring up security and that the fact that you have a bit of a more central governance point allows you to apply security and policy kind of generically across everything. So that is a very helpful aspect of a shared platform. David, I see you raised your hand.
I was going to say more or less uptime and or ease of use. Because it's like if I'm in a situation or in a group that has less people, I don't have the luxury of having 6, 7, 10 developers on staff or those individuals who do all this type of stuff. If I'm able to do 3/4 of stuff as myself and then leave it to somebody else, their level, that makes a little bit easier because you necessarily, from these capabilities, a lot of times you have maybe one or two people, maybe 3 people to do all this. And portals, all these capabilities, but you have to kind of realize it's not, one size fits all. I'm not Walmart or I'm not JB Hunt or I'm not, that big of an organization where if I'm using, OpenShift or these capabilities, these capabilities, they don't have the manpower to do it all. Does that make sense, guys? Excuse me.
I'm hearing it's important to keep in mind that one of the core values that this provides, and we'll talk about that in a minute, is that we can shift down. If you have a good interface at the top, portals and APIs, templates and docs, then we can shift down the complexity of the rest of these capabilities into platform engineering, into platform teams. That makes sense. Yes, Abby. Hey, how you doing?
Hey, how are you? Yeah, I think it was really interesting because we seem to be sharing what I kind of sometimes see a split between like cross-functional requirements of the platform and capabilities that people actually interact with through these APIs, maybe scripted or portal or otherwise, in the sense that like I think security and observability are examples that fit into both categories. Like there's aspects that should just be true across, like cross-functionally across everything. There is security and observability built in, but then there's also things that people might access specifically to those cases. And then something like reliability or uptime is something like that I think I saw is like something that that's something that you have to sort of provide as a part of the underlying like system health or confidence builder for people. So do you find, Josh, like is there a way to split that? Do you see splits there between things that are characteristics of the capabilities and things that are actually the capabilities themselves, or how do you talk about that?
Yeah, we should, I'm going to bring up the maturity model later, and that I think in that you'll find a given component might progress through several levels of maturity. Is it, does it have observability, say? Does it have the full reliability that you expect with backup and restore or high availability? Yeah, there are aspects, I guess you could say, of each capability. All right, let's keep going. Another reason why platforms have become a big deal of late is in part because of an understanding and a shared understanding that we've developed from the team topologies ideas put out by Matthew Skelton and Manuel Paez. And they talk about, this diagram that I created is not one of their diagrams, but they educated us on the idea of a platform team, a shared platform team, which can support many stream-aligned teams. And a stream-aligned team means a product team, a team that's creating some sort of value for end users that the company or enterprise is producing for end users. So it happened to, they didn't necessarily apply it to cloud native platforms, but it coincided with the same, trends that we brought up in the last one, that there's a lot of distributed capabilities that now need to be managed. Well, we can have one platform team in support of many stream-aligned teams. And, by sharing that work, shifting more down into a shared team, we can accelerate the work of those stream-aligned teams a lot more. So that also came out. That's also influenced a lot of people's thinking. A third concept, which really, when we talk about cloud, and I guess I could ask people, what does cloud mean to you? Sometimes people say someone else's computer. I've asked that before and got that answer, which is kind of true. You're outsourcing infrastructure or outsourcing components to someone else. But really, in a way, another huge aspect of cloud is that what used to be hardware, what used to be I have to rack up a server to get something going, I have to connect network switches, I have to, get a hard drive. Now it's all software. So at the same time as, there's more pressure to provide these capabilities, there also it's becoming easier to iterate on infrastructure capabilities because it is software defined at this point. So whereas, our application developers were already in getting more agile and adopting DevOps and iterating more quickly, perhaps, 10 or 15 years ago, that's only starting now to trickle in to our platforms, to our underlying infrastructure, because we get the ability, it's a lot easier to iterate on software and virtual machines than it is to iterate on hardware. So another influencer. So that's kind of led to the platforms that we have now, the need for the platforms that we have now. And now I want to talk about what exactly platform engineering means. And to me, at first, this has been a bit of a journey for me too. At first, to me, platform engineering, well, of course, that means engineering platforms. It just means putting them together. But what I want to capture here is that what's really emerged over the past year or two is that it's much more than that. It's about building bridges. And I just put this down here to kind of illustrate there are a lot of bridges that the platform team has to work through. There are a lot of different teams that the platform team ends up interacting with. And it becomes more than just a place for, here's a platform and go use it. It becomes something that brings people together. What do you need from this platform? What does security need from this platform? What is the business expecting from this platform? So platform engineering becomes a point where we bring together, like we see in these train diagrams, or on the right here, it's actually a platform where a lot of trains are coming in and interchanging and interacting. And in that way, the platform engineering movement or the platform engineering model or idea is really just a continuation of what we've been doing for a little while with DevOps. DevOps is not always such a clear term. We could argue it means, practices. We could argue it means certain tools. I like this diagram because, and you can see the source, I borrowed it from a SolarWinds article. But it looks very similar with all of the components that it requires, all of the capabilities that it requires, to the diagram that I showed earlier about platforms. Because a lot of the DevOps ideas has been about speeding the use of the platform or infrastructure or capabilities for application developers. So platform engineering is not so much any sort of replacement of DevOps, but it's continuing that idea of, can we bring people together? Can we learn and can we learn from our users and together release software? Can the application developers work together with operations folks, with platform engineers to release software? Yeah. And here I wanted to kind of bring up a pattern that I found in customers that I talk with. And again, I want to open this up and hear if it's something you find in your organization. But what I found is that a lot of customers talk about, of course, their app teams, and they talk about lower level infrastructure teams, maybe that rack up servers and networks. And then they talked about a team that is their DevOps team that provides, say, pipelines, or some of them provide Kubernetes, or some of them manage GitOps processes. So I wanted to kind of characterize what I've heard in that area. You've got your platform engineers, which maybe run Kubernetes and Tekton for you, but then we still expect our application developers to run the pods that run on Kubernetes somehow, to run the pipelines and observe the pipelines that they create in Tekton. We expect the platform engineers, maybe at this point, and it depends on your organization, maybe they manage the overall database management system so that users can get databases. But we still expect application developers to come in and request a database. And the same thing going down. We expect the platform engineers to handle our observability system and provide us the ability to collect telemetry, but we still depend on application developers to actually instrument and observe their applications. So again, I'm trying to kind of relate this back to DevOps. You build it, you run it, but that doesn't contradict the fact that there's a shared platform that we run together. It's not like me as an application developer, I need to run the platform as well as my application. David, I see you have your hand up there. Do you have experience with this kind of?
Well, the question I was asking Josh, and I was going to ask, is you're saying that you have a platform engineer. Would the platform be more agnostic than running, just like Kubernetes and Tekton or what have you? Would that be, is that more of an agnostic versus, how do I call it?
Yeah, I'm being
does that make sense?
I think so.
I think
are you saying here I've chosen to say they run Kubernetes, but of course it doesn't have to be Kubernetes. I mean, you could run sort of VM infrastructure as well, or Apache Mesos,
or RHEL or something like that.
VMs with an operating system, depending on the needs of your organization. I didn't mean to be prescriptive with what it says here, but even in that case, I think it would still be, the platform engineers run the VM management system, and the application developers request and run a VM.
Right. And that's what I was going to ask, because I'm looking at the slides, Josh, you put in here, and it's kind of like I would have figured that the platform engineers would be more agnostic to what their current environment is, not necessarily being pigeonholed is not the right word, but led down the path of using Kubernetes and Tekton or whatever. Does that make sense?
So do you mean like they might be more responsible for creating a pipeline or a golden path and not actually running Kubernetes or Tekton? Even if somebody chose Kubernetes and Tekton, are you saying is a platform engineer the person that writes the pipelines instead of runs Tekton?
Yeah, that's possible. Or a platform engineer could be a system engineer, that, or a system admin that maybe he's running I'm gonna use that VM cluster, or a bunch of RHEL servers, bare metal or virtualized RHEL servers. Not necessarily just using the moniker Kubernetes Tekton. That's what I was asking the question. I'm just got to understand what the actual definition, for lack of a better term, is.
Yeah, talking back over here on platform teams, I think anybody that is supporting a stream-aligned team with a shared capability
or goal. Would it be even more same capabilities and or goal?
that's kind of what we're adding on top and saying in the platform engineering mindset, yeah, let's work together towards shared goals. We're working together.
Okay.
You as a Streamline team require certain capabilities from the platform, and we make sure to provide them.
Like I said, I'm not trying to be difficult or trying to steer the conversation at a different angle. I'm just,
Sure.
I'm, trying to, understand the, how to call it, a different job title, maybe. I'm not sure how you would say that. Different moniker.
Yeah. I suppose it's the folks, to me, a platform engineer are the folks that are interacting with the app devs at the top. So it's the layer underneath app dev. Is it, I would be curious if in some places we're seeing the sysadmin folks, approaching more of a platform mindset and providing, higher level capabilities straight to the app developers. And in that case, yeah, they're also part of this story.
Okay, fair enough. I'll be quiet for now, Josh
Any other
and
opinions on
Abby.
that out there? Anyone else have an opinion on how you might define a platform engineer in your organization, or how do you define it? Does anybody here, have that title in their organization, and what does it mean?
I used to have it before. It's basically, I used to be a system administrator and then eventually got a platform engineer. So basically my customers are the application developers, application support. And I'm responsible of infrastructure. I'm part of the infrastructure operations team.
And does that for you extend all the way down to, hardware in your data centers?
Most of it. So I don't, for example, manage databases. There is another team to manage databases. I don't manage networks. So basically the platform engineer was part of operations, part of the infrastructure team.
I actually kind of think that is not a terrible pattern, to be able to lift up the entire infrastructure team to serve as a platform to app developers. But yeah, I just put this separation because I had heard from others less that way. Does anybody else is it the same? I wonder often the VM team, because that's one that I found. The team that provisioned VMs is not the team necessarily that provisions Kubernetes or that manages pipeline runners and task runners. But maybe that's changing.
Josh, I have a spin on it. I was theorizing that for the Edge special interest group that we may need to become an Edge platform engineering team so that we can faster design our use cases, because that's critical to us getting things validated and how we train and how we build our testing infrastructure.
Yeah, I love it. I'm putting up my heart sign here because you're giving me another example of that definition of platforms, and that's why it's key that we wanted to define it pretty agnostically, because yeah, you have an edge platform which specializes in that use case, operational edge or something like that. Yeah, I would agree with that. Abby.
Yeah, I think that idea of being able to focus on the practices that are becoming popular platform engineering around like user focus and user experience and all that, regardless of what team you're on, is awesome. And I think that I think Josh, you said at one point, it's like it's platforms all the way down, right? So whether or not your customers are software application developers who are deploying kind of web apps that non-employees are using, or whether your customers are other fellow colleagues who are building higher level abstractions on top of that, it's still applying of platform engineering, of that idea of building something for customers. And so if you're an edge specialist or a VM specialist or something, you might be a platform that another platform team actually depends on, right? That they're your customers because they're building the test environments that people are leveraging the edge compute for and stuff. So
yeah, really good point. Yeah, that edge platform may be relying on another central platform to communicate or something. And that lends nicely into this next slide. So one of the, in our group, we produced the paper to kind of define platforms and help everybody unite on an idea of what a platform is. We've been advancing the concept of platform engineering with the platform engineering maturity model and what exactly, it means to be a mature platform engineering organization. But one thing which is kind of implicit in there, but we maybe haven't stated so explicitly, is that a key component of this platform engineering idea is to treat your platform as a product, which we've kind of been touching on already here with collaboration, understanding the needs of your application developers, catering to their use cases. Those really come down to practices that a good product manager applies, when releasing a product to the general public. Collaborating with them, understanding their use cases, getting feedback, making sure what you're providing actually meets what they need. And just to define a product, I believe what we mean when we say platform as product, it would be useful to define product. I believe what we mean is something that is produced by the enterprise to go out to somebody else, as opposed to a platform, which generally is internal. So generally, a platform is not really a product that you sell to the outside. And therefore, classically, a platform, the value of the platform is determined in a different way. Maybe it's funded as a cost center, for example. There's a central IT team that provides the platform, but that's just a sunk cost. Whereas when you start to treat your platform as a product, in particular, I put down as the subtitle here, value is determined by users. That's the key difference between something which is just an internal, requirement versus something which you're creating as a product for someone else to consume. Do they value it? Do they want to use it? And, one particular aspect of that which might stand out is, would they be willing to pay for it? So some model where, they understand how much it costs, or they're even actually paying for it, might be part of this. But ultimately, the goal is focus on the value that the platform is providing to the users, and determine what goes into the platform based on what those users need. So that's been a pretty big concept, an important concept to think about with platform engineering, not just the collaboration, but treating it as a proper product, customer-centric, making sure that you are meeting your users' requirements. So to sum up, what is an internal platform? That's basically what we're talking about here. And sometimes I like to say, just like you can't buy integration, you can't buy an internal platform. It does come down to some aspect of it you have to own. But nevertheless, a lot of it can be delegated to other providers as well. But anyway, I'm not sure that's the point here. The point is here, what exactly goes into an internal platform? It's important to build it as a customer-centric product. It's important to provide that pleasing user experience. A lot of times that means, excuse me, I'm just going to sit down real quick here. A lot of times that means self-service APIs, documentation, making sure you have everything that's necessary for users to succeed. It's important that it abstracts away the underlying infrastructure. And all of this, we talked a little bit about the why, but all of this, the reasons why we are pursuing all these things is ultimately for some of these reasons on the side. We're seeking to reduce cognitive load on our users by delegating more by shifting down more to the platform team. We're seeking to improve reliability by assigning experts and a shared team that's focused on those shared capabilities. We're ultimately seeking to accelerate delivery of those end user products that your enterprise or your company is seeking to deliver out to the market. And by having a shared team and a shared set of capabilities, you're reducing the amount of work that the product teams have to put in. And last but not least, efficiently integrate managed services. Like I said, your internal platform, you must own it. At least the final layer, you have to integrate it into your own environment. But by having a platform layer, a common consistent platform layer, you can more easily integrate managed services from service providers like the big clouds and other providers. So this is kind of where we've arrived with platforms and platform engineering in the past couple of years. So I wanted to take a moment here and describe how the platform engineering maturity model kind of illustrates this in a little bit more depth, where we go in kind of, and you could apply this to the platform generally, or even to individual components, like we were saying, a way to assess the current state of either your platform as a whole or individual capabilities within that platform. So this was something that our group created. We created the first paper, but then we got a lot of feedback in a practical sense. If you've explained to me up to this point what is a platform and why it can provide value, but now what can I do to actually achieve these things that you've promised? And here also, I'd like to hear feedback where people have found themselves on this chart. Where you find yourself today. We have a theory that a lot of people are operational, are at level 2, and we'd like to encourage a lot of folks, but not necessarily everybody, to get to level 3, to a more scalable platform. But let's just talk about these different categories and some examples of them. So for the first, and these are all about, we can think of them as kind of relationships. So the first one is investment, and this is how your company as a whole, your executive leadership, how do they decide, how have they valued the platform? How have they invested in it? And in particular here, we think about funding of the team, staffing, have they dedicated people to it? Do people only work on a voluntary basis? I actually talked to a company one time that had a well-established platform practice, well-staffed, even with a support organization, they had. But then there was another team that I talked to in the same company, which there was another person that was running a mini platform of their own for some data visualization purposes. And it just struck me that within the same company, you might have different levels of investment in different platforms. Like we said before, you might have several platforms built on each other, platforms all across, platforms all the way down. So even within the same company, you might have an opportunity to assess, how are we investing in this platform right now? Are we treating it as a product, which would mean, we're interacting, it's funded based on the value that it's providing to others. Moving along in the adoption category, we talk about how is it that users find the capabilities that are available? How is it that they end up using an internal platform? And here as well, we find in a lot of companies, a lot of folks are at the first or second level, where some sort of extrinsic push comes in and says, okay, you have to adopt because your bonus depends on it, or because that's the only way you're going to get support from the people that maintain, this capability. If you want a database in this company, then you have to use this one. Whereas in a more complete platform engineering environment, we would hope that there would be an intrinsic pull. So somebody told me that in order to get folks to use their database product, they added observability to it. And of course, if you can get to participatory, where people even want to contribute to your product and contribute to your capabilities themselves, of course, then the adoption becomes even more intrinsic. It's my own thing that I've built. Continuing down, we talk about interfaces, and this is where, before we talked about interfaces versus the actual platform, how is it that you allow users to interact with your platform? Do you have standard APIs that they can interact with, or at least a standard ticketing system, or is every single thing a different call to a different team? Moving down even further in the operations category, and this actually comes back to what David was bringing up before. How is it that we manage the capabilities that we provide? So for example, in the simplest way, we don't really even have a strategy for what we're going to provide. We, on request, on demand, the team that's noisiest needs a certain capability, so we provide that. In level 2 operational, at least some central team is aware of everything that's being created, even if no standards are in place. As we get to centrally enabled, then the central team can start to apply certain practices and enforce that you need backup and restore, or you need observability added to any capability, or you have to make sure that everything is scanned for security purposes. And then, of course, managed services, where the entire capability is almost boxed up and completely consumed like I would consume a cloud service. I don't even have any awareness of what's happening behind the curtain. And then finally, measurement. We've also found a lot of teams are struggling to find, although they may do some collection of metrics, but struggling to find where are the insights into whether I've been successful with my platform engineering effort. What are the productivity metrics which I should be measuring, or what are the aspects in my organization which can tell me that I'm succeeding with measurement, with my platform? So, for example, are the DORA metrics sufficient? Do I need, net promoter score? Do I, what are people adopting my platform and happy with it? Insights into how long it takes for people to onboard onto the platform. Say time to 10th PR is a popular one that Spotify brought up. So trying to go from just collecting metrics to actually deriving some insights from them. So the idea of this maturity model was, okay, so we kind of described what platforms are, what platform engineering is. Now let's talk about how you can actually grow within your own organization. And I guess I'm curious, is there anyone that finds themselves in a particular box on this thing that wants to talk about that? Is there anyone that finds themselves in an extrinsic push, let's say, for adoption? Or is there someone with an intrinsic pull? And what does that look like? Yeah, Waleed.
So I managed to find the hand. I would say some of them, like let's say the organization I was before, you can consider it L2, but they miss, for example, the measurement. The measurement was ad hoc. They had like a wish to go consistent collection stuff, but it was not perfect. So sometimes it's not like a straight line. It's
Right,
like
right,
spiky
exactly.
line
Yeah,
between L2 and L3, and sometimes even goes back to L1.
that's good to know. Yeah, because we expect people will find themselves in different places on here, and that's exactly the point. We want to help them see, oh, we're only collecting metrics in an ad hoc way. What if we start consistently collecting them? And then what insights might we derive from them next? That's kind of the idea.
Yes.
So before we get too short on time here, I'll go ahead and just describe. I said that I would talk about portals and orchestrators. So I put portals first because they're the first thing, and I think they are so popular right now. Everybody talks about internal developer portals, and I think that's because they and the APIs that a platform exposes are the first thing that you encounter. And they are, you might consider them lipstick, but they are very important, and they can make a beautiful platform much more beautiful. Of course, if it's not beautiful to begin with, they might not help that much. So what comprises these portals? Oh, well, before we get into that, let's just talk about what it means interfaces. And I called this my iceberg diagram, and somebody earlier had pointed out it's important to always provide an API to whatever kinds of capabilities you are offering, and the portal should layer over that API. So I think it's important to call out the portal is at the very top, and even though it's the first thing you see, there's a big iceberg underneath. And I wanted to mention there are a few different kinds of portals. So up here I've got, of course, Backstage, very popular these days, but also a couple other ones that people don't even think about. First of all, Headlamp is one that's in CNCF, but the reason why Backstage in particular has become very popular, I think, is because it's very app centric. very oriented towards what an application developer would need from their platform. So as opposed to that, you know, Jaeger, that's the picture of the Jaeger mascot there. That's of course a portal of sorts for observability, but very focused on one specific use case. Argo CD, on the other hand, I put that in there. You know, you go into the Argo view. I've had people tell me that one of the biggest benefits of GitOps is the instant visibility into state. So in some ways, the Argo CD UI is a nice application-centric view as well. So anyway, so we have a number of GUIs, a number of types of APIs. Oops. But the problem that Backstage is coming to solve, and these new developer portals is coming to solve, is really this problem of infinite bookmarks. I borrowed this from a Red Hat deck, where a developer has to jump around to many different things to find the context of their application or component. And so what we've come up with is developer portals, a one-stop shop, really for the top 3 use cases, really for Backstage. A, to provide a software catalog where you can find all of the components and services and capabilities available in your organization. B, to provide an application dashboard where I can see in context of my application all of its issues, all of its pipeline runs, observability statistics, things like that. And C, project initiation, a place where I can start a new project, create from a template, or add a capability to an existing project. I did want to, let me see what I have in my next demo here. I'm just gonna jump to the demo here and kind of show you what this looks like. So if I go to, let's say here, this is a Backstage implementation. This, like probably all of you know, Red Hat Developer Hub, which was actually formally announced yesterday, which is a project built on Backstage upstream, and provides these portal capabilities, which we just mentioned. And you'll find here what I just was listing. First, the software catalog. None of these are all that exciting, but a bunch of components that I've created that it's scraped from my GitHub organizations. Then you can get a view into any individual component, take a look at its application dashboard, and get in context things that are related to it, you know, its images, its latest deployments. And then finally, a place where I can create new projects and, you know, initiate and get started with new projects as well. And that's kind of the goal of a portal, and it really can it can make it much easier for developers to find what they need quickly. That seems to be a big draw of this, that the team can center on this collection of in-context information, and then are able to create new components and new projects from the same, and onboard and add them to the same catalog. I did want to emphasize before we wrap the last bit of a platform, which I'm going to summarize that whole bottom part of the iceberg as the orchestrator. And it sometimes gets overlooked. It's the wizard behind the curtain. You see the portal, you click and you get a template created, and you know, maybe some GitOps process makes it happen. And you don't think about that GitOps process. You don't think about the runtime domain where those things are being pushed out and run. But that's actually a really key part of any given platform. So what is an orchestrator exactly? It's something that can take what I've asked to be created and actually make it happen. So in this case, I'm using the AWS API, and maybe that's not the best example of an orchestrator. Maybe CloudFormation or Terraform layered on top of it, maybe the orchestrator. Something that actually takes what I've asked to be done and calls into the runtime and makes it happen. An interesting thing, though, that it very much overlaps is, if you've heard of operators, which, you know, most people that have worked on OpenShift know what operators are. The definition of an operator is something which encapsulates all of the organizational knowledge needed to run a given kind of component, a given kind of resource. So in fact, in a lot of ways, an operator, especially a collection of operators, is very much like any other kind of orchestrator. It takes what I've declared via my portal, via my project templates, via my GitOps repo, and actually makes it happen. And I think it's worthwhile calling out that at the bottom of a lot of our platform stacks nowadays, we do find Kubernetes and its patterns, its operators and controllers are doing the heavy work of orchestration. If you've done a lot with operators, I don't have a ton of time to go into it now, but there are, at this point, you know, of course, when Kubernetes first came out, the only things that it could manage was compute. Well, most of what it managed is compute, network, and storage with pods and volumes and services. But especially with the introduction of custom resources and custom resource definitions, it became possible to orchestrate all parts of your platform using Kubernetes or using custom resources or high-level APIs created with custom resources in Kubernetes. So it becomes possible to manage Apache Spark databases, certificates, even VMs, say with KubeVirt. We have things like Crossplane, which come along, which make it easy to manage cloud services as well. So the person behind the curtain, the wizard behind the curtain, can be Kubernetes. Kubernetes can do a lot of this work, and especially in OpenShift, I think that we find this is the case. You can choose to use Kubernetes as your orchestrator. And in fact, one of the a popular talk at the last KubeCon was about a stack called the Back stack, which stands for Backstage, Argo CD, Crossplane, and Kyverno, but you might also say Kubernetes, which is very similar. Argo CD, when you're using Argo CD, and in fact, that's my next slide here, it's really just the Kubernetes pattern, but applied for an individual application. So when you do GitOps and you apply a bunch of manifests into your cluster, you are kind of orchestrating your application. Yeah, that is your orchestrator. You're using Kubernetes for your application, just like you might use it for infrastructure. So the GitOps pattern kind of leverages Kubernetes as orchestrator and becomes that heavy lifter behind the portal in your platform. Another important aspect, which I just wanted to mention, and we have this in OpenShift as well, is another part of your orchestrator can be pipelines. Because likewise, they can, like if you've defined a pipeline to carry out action, that also is going to orchestrate how how something can be deployed. Or how something is built, but ultimately for orchestration, you might choose to use something like GitOps, or sometimes you might choose to use something like pipelines. Yeah, and all of these are available within OpenShift to act as your orchestrator. And so I just
Josh, just a second. So I just want to say that we have 5 minutes left. I see a couple of questions in the chat. Not sure, just informing in case you want to leave some room for questions.
Yeah. So the last thing that I was going to show is just this, which is kind of bringing together the portal experience where you're defining a golden path and you're creating a template. And what happens is you check that into a repo, and from that point, the orchestrator picks it up and makes sure that the stuff that you declared takes place. So kind of bringing it all together, you got your portal where you initiate your project. You've got the Git repo as your interface into the orchestrator, and then of course the orchestrator does the heavy lifting in the back. So to summarize, we've got platforms. They help us aggregate a consistent collection of capabilities. Platform engineering is emerging as a discipline to provide these kinds of platforms and capabilities as a product to users. Really important aspects of a platform that you need to think about is your portal experience, but don't forget about the orchestrator behind the curtain. And OpenShift, Developer Hub, and even the console, which I didn't really talk about, are good portals, and Kubernetes itself can be a great orchestrator. So yeah, let's pause there now, and we've got about 5 minutes. Yeah, does somebody want to raise some of the questions, or?
I see already a question from Ben. Ben, do you want to ask the question yourself about the baseline cost?
Yes, let me, my question was, is there any baseline cost, or to a platform engineering setup or technical debt? Like if you're starting from scratch, what would a organization need to invest into if they're doing it from ground zero?
You know, the first thing to do is understand your use cases. Like we said, the ultimate goal of a platform is to serve some use case of an engineer. So if you're looking where to start, it probably would be talking to your application developers, understanding their biggest pain points, the capabilities they most need. Security comes up pretty early. Pipelines and GitOps is a popular place to start. Does that make sense? Like if you're looking to start with your app dev, start with the use cases.
All right, that sounds good.
Yeah. Any other questions, or should I look into the chat here?
We have 2 minutes left. I think we covered Ben. Any other questions or last question to say?
Hey Josh, can we get a copy of the show notes to the slide deck, please?
Sure, I think so. I think I can just post it into the OpenShift Commons
Okay.
Slack.
Because there's a lot of stuff in it that may or may not have gotten to as far as understanding what a platform, the topic. That makes sense.
Sure.
Jockey, does it make sense for you also to share the white paper in case the folks haven't had a look at it? White paper, the stream paper.
In fact, if you want to check it out, you can go to this site. I should have put up a QR code, but tag-app-delivery.cncf.io, and you go to the platforms working group. So you can also just go to /WGS/platforms, and then you'll find these. But I'll put it into the deck, and I'll share that out after also.
Thank you, because it makes a lot of difference for us because we can look at it, kind of get an idea, wrap our heads around the platform engineering concept.
Yeah, please do. I think that this will give a lot of insight. And there is a platform engineering channel now in the OpenShift Commons Slack. And if you want to have conversations there, I'm going to be hanging out there, and I'd love to chat about what you learn or questions you have.
Awesome. Thank you, Josh. That was insightful, at least for me. So yeah, I think we're done with the Q&A. If no one else has any questions or comments or concerns for the future, yeah, speak now. Otherwise, we're done. Thank you all for joining, and looking forward to seeing Karina back again next week. Wishing her speedy recovery, and yeah, thank you again. Have a good one.
Thank you.